Hey everybody, welcome to CIS 39. Today we are going to cover lesson number 14 on the Introduction to Architecture and the Basic Forms. Today I am going to cover these two handouts right here, and these are informational items. They contain information about the different architectural eras, the types of materials that were used to build during those eras, and different innovations that occurred during those eras. It also goes, we're also going to talk a little bit about the idea of what architecture actually is. The next handout is going to cover the different forms and the different primary shapes and elements that we can use to incorporate into our design for our buildings and structures. So let's go ahead and talk about architecture. Now, as I go over these slides, I think it would be a good idea for you to get out a piece of paper and pencil and take some notes as I discuss the different topics, because for your final project, you are going to have to come up with a proposal for some type of structure that you would like to build, and it will be based on the information that I give you in the lecture that I'm about to give. So you may want to pause right now, go grab a pen and paper, and make sure you take some notes. All right. So architecture, eras, form, and order. So what is architecture? Well, what is an architect? So classically, we like to think of somebody by the name of Daedalus as the first architect. So Daedalus was from the island of Crete, and the story, the myth goes that at the time there was a minotaur running rampant across the land of Crete, wreaking havoc on the people that lived there. So the king of Crete, by the name of Minos, I can't remember. Oh, Minos, King Minos, commissioned Daedalus to build the labyrinth. The idea being that they would be able to trap the Minotaur there to keep him from further wreaking havoc on the people. And it worked. The Minotaur got lost in the labyrinth and was trapped. The story goes that a hero by the name of Theseus heard about the labyrinth and the Minotaur, and being the hero that he was, he wanted to go there and slay the Minotaur and further increase his reputation. So Theseus made his way to Crete and met the king's daughter along the way, and of course they fell in love. The daughter, not wanting Theseus to come to harm or become lost in the labyrinth himself, went back to Daedalus and begged Daedalus to provide some method by which Theseus would be able to get back out of the labyrinth. The solution from Daedalus was to give her some thread that Theseus could unspool as he made his way from the entrance into the labyrinth, and then he could backtrack using the spool of thread, or the line of thread, to get back to the entrance and make his way out. And the plan worked. Theseus killed the Minotaur and met back up with the king's daughter, and they fled together. And the king was not really happy about this, that his daughter took off with this person, so the king punished Daedalus by imprisoning him in his own creation, the labyrinth, along with his son. And then the last part of the story is that Daedalus and Icarus were able to fashion wings and together, or wings out of feathers and wax, and transcend or fly out of the labyrinth to their freedom. Now this story does a couple different things. First off, it incorporates the idea of building upon the earth, establishing a place, and using a path. And the labyrinth is conveniently both a path and a place. It helps us to identify things such as center, enclosure, walls, halls, doorway, and not almost, but probably most importantly, it presents the idea of narrative and drama. Now, the reason that that's important is the notion of flying out or transcending is important when it comes to architecture. Different structures have different purposes. A church versus a hospital, they have very different functions. So how is it that the shape that you choose for the building supports the narrative or the function of that structure? So we'll talk more about that in just a little bit. So the word architecture actually comes from two words, arch and techne. Arch meaning the first principles of the world that underlies all of reality, or origin. So you can think of the word arch as origin. And then techne means craftsmanship. So if we put these together, we have identifying a spot on the earth or origin and artistically building upon it. Or the art and science of designing and erecting buildings. But this definition, the art and science of designing buildings, doesn't cover everything. So buildings are just a pile of different materials: wood, metal, stone, and glass. Now, nothing about the materials themselves supports this idea of narrative or transcending to allow us to really sort of feel what that building's function represents. The other thing is that buildings, typically when we think of a building, we think of a structure like a house or an office building, a church, a theater. We think of a place where people gather and perform some purpose. There's some job. So, for example, you go to church and you worship. You go to a theater to be entertained. People gather at office buildings to do work, right? But structures other than those types of buildings are definitely considered architecture. So things like monuments, piazzas, bridges, towers, tunnels. Now notice the difference is that these are not enclosures like houses or office buildings. You don't go into a piazza. Oop, hold on. Mouse. Sorry. Forgot to click it on the. I was going to try to highlight this word, but I forgot clicking on the mouse advances the PowerPoint. So anyways, a piazza is a large opening that people can gather in. A bridge, people don't gather and stay there. They use it to cross a gap and continue along their way. So the main idea is that I don't want you guys to think of this architecture as just buildings. Think of it more of the word structure. So an architecture can be lots of different types of things. Okay, at its essence, architecture should strive to inspire and illuminate. So, for example, think about something like a church. A church is going to have ceremonies that occur there, like weddings. Weddings involve things like processions. So how can the structure, the form of the structure, facilitate that idea of a wedding procession? How can the space of a theater be arranged so that it can accommodate large numbers of people and that all those people can easily see the performance that is occurring at the theater? So how does the form that you choose for your structure support the function of the structure? So as an example, let's go ahead and take the Lincoln Memorial, something most of you are probably familiar with. Hopefully you're familiar with President Abraham Lincoln, who served as president during the Civil War and is most well known for winning the Civil War, for preventing the country from being divided into the North and the South. So what are some of the things that the architect wanted to do at the Lincoln Memorial? Well, one of the things that should stand out to you is obviously Abraham Lincoln in the middle. Other things that should stand out are these large columns. Now what you may not be as obvious is the symbol above each column. Each one of these symbols represents one of the 50 states that Abraham Lincoln held together in winning the Civil War. So it's not a coincidence that these symbols are placed directly above these large supporting columns. And the other thing that these columns do is sort of have this vertical orientation that sort of draws the eye up towards the top and then right towards that symbol of the state. As you make your way inside the Lincoln Memorial, notice some of the considerations. They don't want to clutter this space up. We want to accommodate large numbers of people, so the design is left very open. And the actual memorial of Lincoln himself is very accessible from many different angles. Also, the use of the columns, again, used to draw the eye up. And then the actual statue of Lincoln himself with the quote here above him, and symbolically one hand clenched as a form of strength or firmness, the other hand open to represent the gentler side of Lincoln and the compassionate side of Lincoln. So anyways, the idea is that the actual Lincoln Memorial itself is just a bunch of marble, right? But it's the way that that marble's been arranged. It's the forms that were chosen. It's the shapes that were chosen that evoke that symbolism, that support that narrative, that support the function of the building, which is to memorialize Abraham Lincoln. All right. Next, I'm going to talk about the different eras of architecture. And the main thing that I want you guys to think about when I go over the different eras is what were the types of materials that were available to use, what were the different innovations that allowed the different types of architecture to be created. And just to give you a quick overview, we're going to the eras are generally considered pre-classical, the classical era, not the Dark Ages, the Gothic era. I'm forgetting my own stuff. classical, why am I forgetting? The Middle Ages, thank you, not the Dark Ages. The Middle Ages. Middle Ages, the Renaissance, and then the Industrial Revolution, and then finally the modern era. So those are the different eras that I'm going to talk about here right now. All right, so let's start off with the pre-classical era, and I'm going to be focusing mainly on monumental architecture, so large architectural projects or structures. So let's start off with the pyramid. So one thing that's interesting to note about the pyramid is that when we talk about monumental architecture in the pre-classical era, whether it's in Egypt or all the way across the globe in South America, we find that the overall shape of the architecture is the same. It's a pyramid. You may say, so well, how is that? How is it that during the pre-classical era, different people from all the way across the world who never talked to each other, had no idea that the other people existed, why did they always choose the pyramid? And no, it's not because of aliens building the pyramids. There's actually a very practical reason. So during this period, one of the main components to build with was stone. There was wood and things like that used in other architecture as well, but if we're talking monumental architecture, the most widely used material is stone. So why a pyramidal shape? So in both cases, the purpose of the structure is to do the same thing. Now we'll see that prior to the Renaissance, a lot of the focus of large architectural projects is focusing on things that people didn't have answers to. Mainly the afterlife and what is there beyond the earth. So notice that these structures do a couple things. First off, the triangular shape implies a directionality, so it's pointing up. And this is, again, going to that idea of transcendence. So we're pointing from the earthly up into the unknown. We're transcending. Now, interestingly enough, a lot of times these structures were, the function of these structures was religious in nature. So we have in Egypt, we have the Great Pyramid of Giza. That was the tomb of the pharaoh. And then in South America, we have the Aztecs and the ziggurat. And the ziggurat is where the religious leaders would perform sacrifices, believing that these sacrifices would appease the gods and continue to provide rain to grow the crops. So again, large-scale architecture, mainly using stone, mainly focusing on the afterlife and the unearthly, the unknown. Now this is one of the earliest attempts on monumental architecture. This is called the bent pyramid. And notice that it has this very obvious dent or indentation to the top. And the reason it has this indentation is because if we were to continue the line straight up here, and it's worth mentioning that too in the previous slide, notice that the angle on both pyramids is approximately the same. In fact, if I drag and drop this one over the top of it, you'll see that they match almost precisely. So why did they bend this pyramid? Well, like I said, this was one of the first attempts at building a large pyramid. And simply put, they made the sides too steep. And when you're using large stones to build, the weight becomes an issue. The higher you build the structure, the heavier the structure becomes. And what happened is when they started to get above this line, they started noticing cracks appearing all around the pyramid. So in order to reduce the weight, they had to lower the angle. And you can imagine all the mass that would otherwise be there pushing down that would eventually just cause the pyramid to collapse on itself. You can kind of see that happening here as well. All right, so that was the major limitation of using stone, is that stone is very big, it's very hard to work with, and it's very, very, very heavy. So the solution later on during the classical era, so now we've moved from the pre-classical to the classical era, we have the Greeks. And the solution to the weight problem was get rid of as much stone as we can. Now, the way they did that was using something called post and beam construction. So you can build these wooden frameworks like you see here, and then you can actually move the stones on top of them. You can put columns, and that's the other thing notable, is that Greeks are well known for using columns in their architectural structures, their large architectural structures. And then you could place the columns in and then remove the post and beam framework, and then what you have left over is the actual structure itself. Now it's noteworthy that they're still using very large, heavy slabs of marble during this time. So that's very hard to work with, and it takes a lot of time to build something like that. Now, the post and beams collectively are called a truss, and trusses are still used to this day in construction. So note the use of triangles throughout the bridge. And we'll come back to this idea of the triangle and how triangles are inherently very stable and very strong, and how symbolically we can use that, incorporate triangles in our architecture to evoke that sense of strength and stability. As I mentioned, columns were widely used. This is a replica of the Parthenon in Greece. Oh my gosh, so many tabs. There we go. Okay, so this is another Greek structure, the Parthenon. And again, you see that prevalent use of columns in the structure. And again, very large stones being used. So the idea is that you would use that post and beam or truss woodwork to slowly build this up and then remove all the framework when you were done. Okay. The other thing that's important to note is the use of gravity to keep the structure together. Now, all of those structures that I showed you, the Parthenon, and this is the Washington Memorial in Washington, D.C. The only thing holding these massive buildings together is gravity. So it is the weight of these stone slabs that is holding everything together. So there's no metal inside this structure. There's no steel or rebar. This is all just held together by its own weight. Now, and it's also kind of interesting to note here the change in color on the Washington Monument. They started to build it, and then the Civil War broke out, and then obviously construction had to stop until the Civil War was complete. And then when they went back and finished the monument, the stone at the bottom had weathered and changed color. So there's this distinct line which marks the difference between the pre- and post-Civil War times. All right, so that is the classical era with the Greeks. Let's talk about the classical era with the Romans. Now, the Roman civilization was much larger than the Greek civilization, covered a lot more territory. And so when the Romans wanted to build large monumental architecture, using slabs that were the size of the ones like in the pyramids or in the Parthenon wasn't practical. It took too long. So the idea the Romans had was that you could make the slabs smaller, and thus we have the brick. Now the problem with bricks is because they are much smaller in size, when you start to stack them up higher, gravity cannot hold them together because they don't weigh as much. So it's much easier for the structure as it gets taller for it to fall apart. Thus the invention of concrete. So the Romans invent concrete, and you slap that between the bricks, and that gives you the strength that you need to keep the structure together. So we can see here's two examples of Roman architecture. This is the Colosseum on the left and the Pantheon on the right. And this is another invention, actually two different inventions that the Romans gave us. So it goes back to the idea of removing weight. So you want to get rid of material and lower the weight of the structure, thus increasing the stability of the structure. But how do you do that without it becoming inherently unstable? Well, you use an arch. So the idea of the arch is that the left side of the arch is pushing to this, wants to fall this direction. The right side of the arch wants to fall this direction, and then you place something called a keystone in the middle that allows these to push against one another without collapsing and falling down. Thus the weight of everything up here is transferred down the sides of the column, and the building becomes stable. Now the dome is really the same idea as the arch, except for so imagine if you took this arch and you revolved it, you would have a dome. So it's the same idea. Each opposite side of the dome in the roof of the Pantheon is pushing against one another, holding itself up. All right, so the Romans, when you think of the Romans, think of the use of smaller brick, concrete, the arch, and the dome. They also invented something called the vault, a vaulted ceiling. A vaulted ceiling is if you take this and you make a hallway out of it. So if I just extrude this forward or backwards and create a hallway with an arch on as a ceiling, that's called a vault, or a vaulted ceiling. All right, that's everything from the classical era. Let's move on to the Middle Ages, the era that I couldn't remember at the start. So the Middle Ages, again, we see a focus on the afterlife. So this is the is Notre Dame in Paris. And notice the tendency, or the trend, I should say, to build taller, build bigger when we talk about monumental architecture. So going back to the idea of the brick and the smaller stone, as I mentioned, the higher the structure gets, the more unstable it gets, even if you're using concrete. So thus the invention of something called the buttress, also sometimes called the flying buttress. So the idea of the buttress is that you build these, they're sort of like a half arch. You build these large columns all around the exterior of the building, and then you throw an arch in there so that the weight pushes out and then gets transferred down the column. Same idea as the arch that we saw in the Colosseum in the previous slide. Now again, this idea of going taller, it's that same idea going all the way back to the pyramid of connecting the earthly with the unearthly, or transcending or moving higher up into the unknown, going up. And that's something that goes on to this day, building taller, building bigger. All right, the Renaissance is the next era that we'll talk about. And the thing that's most notable about the Renaissance is the cultural movement away from classical sources and trusting in the individual as the intellectual center. So, in other words, focusing on the worldly rather than the divine. Right? This was the big contributors to a lot of the artwork and architecture during the Renaissance were people like Leonardo da Vinci and Michelangelo. And so now what we see is instead of always building large temples or large churches, we now see things like palaces or schools, universities, hospitals. The focus of some of the bigger architectural projects are now focusing on the here and now, what's happening to humanity on Earth, and less about the afterlife, what happens after we die. All right, so if you're thinking about building something for your final project during the Renaissance period, you're probably thinking about something like some type of like a university, or like. All right. So, anyways, moving on, the Industrial Revolution. So, the major shift here is the use of cast iron in construction. So, once again, cast iron allowed us to remove weight. So you can see this is the Eiffel Tower. You can see that there's very little. I should say that there's holes and gaps, all throughout the structure. So it's the same idea that the Greeks had with the columns and the trusses, is you can remove mass and build higher. But also the strength of iron is much greater than that of stone. So again, we can go higher with our construction. The other major invention during this time is the use of steam power, the steam-powered engine. So now we see the use of railways. So different types of structures that are more common in this area is things like bridges to allow us to connect things together, tunnels, marketplaces, because now we're able to transport things over large distances. So if you're thinking about building something during the Industrial Revolution, think about those types of things: bridges, marketplaces, things like that. And then finally, we have the modern era. And the major discoveries during the modern era that allowed to build things like skyscrapers is the use of steel. So steel, unlike iron, is much stronger. Steel is an alloy. So iron is just a basic element, iron. Steel is an alloy of iron and carbon, which is much stronger than iron. If you build too high with iron, the structure will actually just bend. So steel is much firmer, much more rigid than iron. Now, if you can build something this tall, it doesn't do you much good if it takes people 3 hours to walk from the bottom to the top of the structure. So the second thing that makes modern architecture like skyscrapers possible is the discovery of electricity, which allowed us to create elevators so that we could actually make it up to the top of this building in a reasonable amount of time. All right, so if you're talking about modern era architecture, you can think about things like skyscrapers. All right, and that is it for the first set of slides. So that was everything from this first PDF file called Architectural Overview. The next thing I'm going to talk about is the different forms and different shapes and their symbolic meaning and how that can be used to support the narrative of your structure or the function of your structure to allow that sense of transcendence when somebody views it. Alright, so the next thing I'm going to review is this form and space PDF here. And we're going to talk about mainly three different concepts. We're going to talk about the primary elements that are required to even have a shape to something. We're going to talk about the different shapes and the symbolic meaning that they evoke. And then finally, we're going to talk about something called the order of form, and how the order of form is the overall shape of the structure, which is really just a collection of different shapes. So let's start off with the primary elements. We can't have anything if we don't have a point to start with. And we know that in 3D modeling as something called a vertex. The big thing to note about a vertex or a point is that it is directionless. If I ask you which direction this point is going, you couldn't answer. It looks like it could be equally going any direction at the same time. So a point is directionless. It just has a position. And the two main things that are associated with points, and we'll see later when we extend this out to the idea of a circle or a sphere, the main thing that's associated with a point is the idea of an origin. Now, if we think of it as an origin, we can see that we are starting here and something is originating out of it. But notice that by subtly changing the drawing, by adding these circles, now this doesn't really seem like it's necessarily an origin. Maybe this is now a place that we're supposed to go to. So in other words, if I take all these arrows, I could take all these arrows and just flip them around and make them point to the point. And now instead of it being an origin, it's a destination. It's a place that I'm going to, not a place where things are going away from. And that's an important quality to all the primitive elements, is they have these sort of opposite meanings depending on how they're being used, depending on the context. So when we think about a point, we think of it as an origin, a place everything comes from, or we think of it as a destination, a place everything is going to. So opposite meanings, even though they're the same, even though it's the same thing, a point. Now if we put 2 points and connect them, we have a line or a segment. Now lines, as we see here, unlike a point, have directionality, or an implied directionality, whereas a point does not have any directionality, it just has a place. Now lines, just like points, have symbolic meaning. Now symbolically, they can be used to connect. So I'm connecting this to this. However, if I place a point here above, actually let's look at the picture over here, it's kind of hard to see. If I place a point here and a point here on opposite sides of the line, now the line is being used to separate. So again, we have that sort of double opposite nature to the basic element. So a line can be used to either connect, like we see here, or a line can be used to separate, as we see here, separating this from this. Now we also saw that earlier with things like the column in the Lincoln Memorial, and you have the connection between the ground, the earthly, and then it rising up to meet the symbol of the state. So lines are used to connect or separate. If we add another point, we get a plane or a surface. So we can see here's a point, here's a line. So we have 1, we have 2, and then down here we have 3. And now we have a surface. So surfaces are used to identify where you're supposed to go. So for example, if we lay out a bunch of surfaces on the ground, we form a path. Like think of a sidewalk, or a sidewalk through a park, winding its way through the park, telling you where you're supposed to go. However, if we rotate a plane and place it on its side, we now have a wall. And a wall is telling us where we're not supposed to go. A wall is giving us boundaries and saying, don't go here. You're not supposed to go here. So again, we have a almost contradictory meaning with the same shape. So a plane or a surface takes 3 points and can be used when it's laid out flat to tell us where we're supposed to go as a path, or when turned on its side, represent a wall telling us where we're not supposed to go. Lastly, if we extrude a surface out, we get a volume. And I'm going to hold off on talking about volume until we get to shapes down here at the bottom, but I do encourage you to read through all of these, even though I'm just kind of rushing through them. Okay, so those are the most primitive elements you can work with, is points, lines, surfaces, and volumes. But let's talk now about how we can arrange things differently to create different geometric shapes, and symbolically what those tend to evoke in terms of meaning. And I encourage you to take a look at the symbolic meaning of shapes. Just do a Google for it. And there's lots of different sites that could potentially come up. But you can see like geometric meanings. I think this is a good one right here. But anyways, you'll see that different shapes commonly evoke the same types of sense of meaning. Squares. All right, so let's talk about the different symbolic meaning of shapes. All right, so here's lots of different examples of shapes. Sometimes, and you can see some of these are actually just combinations of different shapes, like a circle with a triangle. Like we have here, we have a circle and a triangle. Here we have squares arranged in different ways. But the three basic shapes are these: circle, triangle, square. And then different arrangements of these three shapes give us an infinite number of different possible shapes. So let's start off with the circle. So the circle is really just a big point, and because of that, it evokes the same type of feelings that we think about when we think about a point. Here we can see the arrows are indicating, going away, that this is an origin. This is where something is originating from. We flip those around, and now this is a destination. This is a place things are going to. So symbolically, when we use circles, we think of things like an origin or a destination. Triangles. The main thing we think about with triangles is the notion of stability. So recall earlier I talked about trusses and the truss bridge and how it was really just a collection of different triangular metal beams. But the reason that triangles are stable is because when we put it this way, as we see it here, when we lay it so that the flat side is on the bottom, it's very, very stable. It's very unlikely that this is going to tip over or fall, right? Now the other thing is that we get an implied sense of directionality with a triangle as well. We'll see it pointing up. Now, just as with the other symbolic shapes having dual meaning, triangles represent stability, but if we place it or orient it this way, so that the top is now on the bottom, this now represents something that is inherently unstable. For this to stay like this, it would have to be perfectly balanced on that tip. And if it moved just a little to the left or right, it would fall over. So triangles represent both stability and instability depending on how the triangle is oriented. Okay. Next we have the square. And I don't like the definition he gives here. He calls it the rational understanding of form and space. Squares are most commonly associated with equality or fairness. So think of somebody saying that was a square deal. It means it was a fair deal. And the reason that that's associated with equality and stability, not stability, equality and fairness, is because in order for a square to be a square, each side has to be exactly the same length. Each angle on the inside has to be exactly 90 degrees. If any of these were different than the other, it would no longer be a square. It would be some variation of a square, like a rectangle. Right? So squares are used to evoke a sense of fairness. All right, so last but not least, we have the primitive shapes. Now these are obviously all based on the shapes we just looked at. A sphere is just a volume that represents a circle. A cone or a pyramid is simply a volume based on a triangle, and a cube is simply a volume based on a square. And the meaning that we just talked about carries over into the three-dimensional versions of those shapes. So origin or destination, stability or instability, and fairness or equality. Now, all we do to create different architectural components is tweak or transform each one of those basic shapes slightly. So in any of these pieces of architecture here, we can see that these are all based on the same basic shapes: the sphere, the pyramid, and the cube, or the circle, the square, and the triangle. These are all just variations of those, basically transformed, and then combinations of those two things. Right? Okay. Last part of this is orders of form. Now, this covers 5 different orders of form, but I'm only going to talk about 3, and you only need to know about 3 for the class. So the first order of form is what's referred to as a centralized order of form. Now, order of form doesn't get specific about a triangle versus a sphere versus a cube. An order of form simply refers to the overall shape of the structure. In a centralized order of form, you tend to see that the height, the width, and the depth of the form, whether it's a cube, a sphere, or a pyramid, all tend to be roughly the same length. So it's very uniform in its distribution of its size. Centralized forms are good for things that require large gatherings of people. So things like theaters, stadiums, all tend to be very centralized in their form. So when you think about whatever building or structure you want to put up, think about what its purpose is. If it's going to need to accommodate large gatherings of people, think of a centralized form. Linear orders of form are used to imply connection between things. And whether it's a vertically oriented linear order of form or horizontally oriented order of form, change sort of the meaning. So when we look at something like a tower like this, typically with long linear orders of form like this that are vertically oriented, we think of connecting the terrestrial with the unknown or the heavenly, right? So that's one of the symbolic meanings of something built like that, versus something that is horizontally linear. So if you connect things horizontally, that's the purpose, is to imply a sense of connection between not the heaven and the earth, but a more practical connection between maybe one side of a gorge to the other side of a gorge using a bridge. So a bridge is a linear order of form. All right, so again, if you're thinking about something that tries to connect, whether it's the earth to the heavens or one side of a gorge to another, you're thinking more of a linear order of form. So here we have a horizontal linear order of form. And then last but not least, we have radial orders of form. A radial order of form is a combination of a centralized order of form in the middle of the structure with linear orders of form that radiate out from it. And the reason for this is if we have to have something centralized that large number of people may need access to. So this is a casino. The casino is going to be at the bottom of the casino, and we're going to want to accommodate lots of rooms for people to stay in. And then so that the linear part of the hotel represents the facilitating of the storage, the place for somebody to stay. And then via the elevator, we can quickly get down to the centralized part of the casino, where the people can easily go down and spend all their money at the casino. The handout mentions clustered orders of form. It also mentions, oh, that's the last one. And yeah, I'm not going to hold you guys responsible for this. So for us, we're just going to work on either a centralized, a linear, or a radial order of form. Okay. So real quick in review, when we think of a structure which is primarily a place for gathering, we think centralized order of form. When we think of a large structure that's used for connecting, we think linear orders of form. And then finally, when we have to accommodate large groups of people getting into a centralized space, we could think of a radial order of form. Actually, let me be more specific with the radial. I said accommodating large groups of people to that would be a centralized space would be just simply accommodating large groups of people. Here we have the linear part that is there for the housing of large groups of people and accommodate getting them to the centralized part of the structure, which is the casino. So just want to make sure that I'm clear on that. Okay, the last part of the handout just gives you different examples of how you can provide transformations to the different shapes to accommodate the space. I will leave that to you to go through the reading. And lastly, talk about the lab. So the lab is actually very simple. Most of the stuff you guys have already know about, how to use the basic tools in Maya to extrude surfaces, to split surfaces, to move and rotate surfaces. So you guys have already done that. If you feel like you're a little rusty with Maya, I encourage you to go back to lesson number, actually I don't think it's listed, but the helmet tutorial, which covers all the basic modeling tools in Maya. So if you're feeling a little rusty, go back and do that helmet tutorial over again, and you should be fine for doing this tutorial. All right, down here, see, this is all just kind of stuff that will let you guys read. It's just setting up the project, creating a cube, showing you the different displays. But really, what you guys can do is, if you already feel comfortable with your Maya skills, is you can just jump right down to this part right here. So for the lab, what I want you to do is choose, these are all examples of centralized forms. I want you to pick 2 of these to recreate as closely as possible. Next, so those are 2 centralized orders of form. Next, I want you to pick 1 of these linear orders of form to recreate. Note that you might be able to incorporate these centralized forms to create the centralized version of it. You're just going to recreate it to the best of your ability. So choose 2 central and 1 of these linear forms to recreate. And then lastly, I want you to create from those a radial order of form. So combine your centralized forms. You can see here's the centralized part of it. Here's the linear part of it. Just combine those together to create your own radial order of form. And if you'd like, you can go ahead and intentionally choose, like this right here is being used to make this part of it. It's just being scaled up and out. And then this one right here is being used to create the centralized part of the radial. So if you want, you can kind of just cheat a little bit, for lack of a better term, and then recreate those ones so that you can recreate this. But again, you don't have to do that. I mean, if you like the way that this looks better, then you can go ahead and use that instead. All right. So that's your lab, is to create 2 centralized orders of form, 1 linear from the list up here, and then finally combine them to create your own radial order of form. All right. And then you can ignore the stuff here on clustered orders of form. All right, so that's the lab, what you can do is, since you're creating multiple models, you can just go ahead and put them all in different layers. So just put your 2 centralized in a layer. That way you only have to turn in 1 project. So you'll just zip up your project and then send that to me via the Canvas turn in, the way you've been doing it with Mudbox. All right, so hopefully that makes sense. If you guys have any questions on anything, don't hesitate to ask. Go ahead and read through those handouts, even though I broke them down for you. Make sure to read through them yourself. Think about what type of area you'd like to build a structure in. Think about what type of order of form you'd like that structure to be. And think about the different types of shapes that you could incorporate into that building to support the narrative or the function of the building via circles, squares, and triangles. All right, that's all for today. So good luck. Let me know if you need help on anything, and I'll see you on the next lesson.